Okay, today's lesson is going to be over circumference and areas of circles, and also finding the arc length and the area of a sector in a circle. So circumference and area of a circle is probably going to be review for you, since that's something that you've probably done before. So we will review that quickly, but we'll really spend some time talking about arc length and areas of sectors. So just to review here, first of all, remember the circumference of a circle is it's basically the same thing as the perimeter of a circle. It's just a fancy word for perimeter. So it is the distance around a circle. And most of you probably remember your circumference formula as being the circumference of a circle is equal to 2 times pi times the radius. Okay. Others, you may remember that the circumference is equal to pi times the diameter. These two formulas are really the exact same thing, because 2 times r is the same thing as the diameter. So these two formulas here, they are basically the same thing. So if we just look at a quick example, if I have a circle that has, say, a radius of 6, my circumference would be 2 times pi times 6, which is going to be 12 pi, and I can just leave my answer in terms of pi, and I don't even have to use my calculator and multiply it out. That's it, I'm done. 12 pi is the circumference of my circle. So it's pretty simple. We're going to use circumference when we talk about something called arc length. Okay, so arc length is going to be a portion or a fraction of the circle's entire circumference. So if I have a circle, okay, when we calculate circumference, we basically calculate the whole entire distance all the way around the circle. When we're talking about arc length, we just want to calculate a small portion of that, okay? So maybe that much of my circumference is all I want for my arc length, okay? Now, when we are talking about arc length, okay, don't confuse it with arc measure. This is something that we did in chapter 10, okay? And we said that arc measure, remember, is measured in degrees. It's the same as its central angle. So if this circle over here, okay, if this has a central angle that's 100 degrees, then the measure of this arc right here is also 100 degrees, okay? But that's not what we're finding when we want to find arc length. Arc length is going to be measured in inches or centimeters. So we have to find that a little bit differently, okay? So this may be, its measure may be 100 degrees, but its length, it may be 10 meters long or something like that from here to here. That's going to depend on what my radius is, okay? All right, so if we look at some arc lengths, okay, right here in red, I have a semicircle drawn, okay? Now we know that a semicircle is going to be half your circle. So we have half the circle here in this picture. And we want to know what is the length of half of it. So we're going to calculate half of our circumference. Here's my fraction, 1/2, and that comes from the fact that I'm using half of my circle right here. And then this part right here, that's my circumference. Okay, 2 pi r, that's my circumference formula. Okay, over here, you can see I have a 90-degree arc. Okay, so if my central angle is 90, that means my arc is 90. So if I think about how much of my circle I'm using, I'm using 1/4 of my circle, okay? So I have 1/4 of the circumference. So in this problem, or in this case, my equation would be 1/4 times 2 pi r. Okay, and then last but not least over here, I have a 240-degree arc here in red. Okay, this is a pretty big arc right here. But if I want to know how long that is, okay, well, if I only have 240 degrees of the circle, how much of the circle do I have? Okay, well, if you think about an entire circle being 360 degrees, what fraction of 360 am I working with? Okay, well, 240 is 2/3 of my circle. Okay, so that's where I get this fraction. It's 2/3 of my circumference. So the big question here is how do we get this fraction? Okay, these three examples, this one, and this one, they were fairly easy to be able to just look at the diagram and see what fraction of the circle I was working with. Okay, but they're not always going to be that easy. For instance, what if I have a 60-degree central angle? What fraction am I working with there? Okay, if I have a 60-degree central angle, okay, well, 60 degrees compared to 360 degrees, that's 1/6 of my circle. Okay, just like when I compare 90 to 360, I'm dealing with 1/4 of my circle. Or over here, when I compare 240 to 360, I get, 2/3 of my circle. Okay, so I find that fraction by taking the measure of the arc and dividing it by 360 and just simplifying that fraction. Okay, so if I had, say, 100 degrees, okay, and I wanted to know what fraction of my circle I was dealing with, I would take and put 100 over 360, and then I would reduce that to 5 over 18, and that's the fraction of the circle I'd be working with. Okay, so let's look at an example. Okay, let's do this first one. This first one over here. Okay, I know my radius is 4. I know the measure of my arc is 50 degrees. And they're asking me to solve for the arc length. Okay, so to do that, I'm going to take 50 degrees over 360 because that is how I'm going to figure out my fraction. And I'm going to multiply that by my circumference. And my circumference is going to be 2 times pi times 4. Okay, now if I reduce this fraction, I get 5 over 36 times, and then my circumference here, that's going to be 8 pi. Okay, and now all I do is I take and I multiply this fraction times this whole number right here. So I'm going to stick that over 1, and I'm just going to multiply straight across. So 5 times 8 pi is 40 pi, and 36 times 1 is 36. And then I'm going to reduce, and 40 over 36, they both reduce by 4. So that gives me 10 pi over 9. And since we're dealing with arc length, we're just going to say units because we don't know if it's inches or centimeters. So that is my final answer, 10 pi over 9 units. Okay, all right, you go ahead in your notes, go ahead and do this example, do this second example right here. Okay, if you're still working on that example, go ahead and pause the video. I'm going to go ahead and move on to area. If you remember area of a circle, pretty much everybody, I think, remembers the formula for area of a circle. That's the one you always think of when you think of a circle. You always think about pi r squared. So that's how we find the area of a circle. We have to have the radius. We square the radius and we take that times pi. So over here on this example that I have, if my diameter is 12, that means my radius is 6 centimeters. So my area would be pi times 6 centimeters squared. So that gives me pi times 36 centimeters squared. And we just write this as 36 pi centimeters squared. And that's my answer. I just leave it in terms of pi. And again, always make sure you label your answers with the correct label. Since we're dealing with area now, our units are now going to be squared. So centimeters squared on those. Okay, the other thing that we're going to talk about in terms of area is how to find the area of a sector. And it says here that a sector is a region bounded by 2 radii. So here are my 2 radii right here that I'm highlighting in green. Okay. And the intercepted arc. So here's the arc right here. So this is the area that I'm looking at. So it's kind of like a piece of pizza or a piece of pie. Basically, you're looking to find the area of that piece of pizza. Okay, so just like arc length was a fraction of your circumference, your sector area, this stuff right here, is going to be a fraction of the area. So my formula looks very similar to the formula I used for arc length. With arc length, this part right here was circumference. But now I'm dealing with the area. So now this part of my formula is area now. My fraction is still the exact same. Okay, so it's a fraction times my area. Okay, let's look at an example of that. So if we find the area of the sector formed by arc CD, okay, and it's a little hard to tell, but this is a 4, and this right here, I'll rewrite it. It's 80 degrees, okay? So we know the measure of our arc is 80 degrees, and we know our radius is 4, and they want us to find the area, okay? So I'm going to say my area is equal to my arc measure over 360 times, and now that I'm finding area, I'm going to do pi r squared. So pi times 4 squared, okay? And I'm going to start off by reducing this fraction. So 80 over 360 is going to reduce to 2 over 9 times 16 pi. My area right here becomes 16 pi. So again, now all I have to do is stick this over 1 and multiply my fractions. 2 times 16 is 32 pi, and 9 times 1 is 9, and I can't reduce this anymore. So that's my final answer, and I just want to make sure I label it as square feet. So 32 pi over 9 square feet is my final answer for this kind of dotted area in there. Okay. The last thing in your notes, go ahead and do this example And again, just in case you can't read this very well, this is 11 meters, and this is 135 degrees. Okay, so go ahead and pause the video and do this example in your notes, and we'll work some more tomorrow with some of these different parts of a circle and finding the lengths of them and finding their areas.